The hardest part about this, we're working with these very poor communities, and there are so many wonderful things that technology offers right now that can change the lives of the poor from even 1 month to the next, transformative, controlling diseases through the wonders of modern medicine or modern public health. There's now mobile broadband coming into the villages of the world is something I'm sure they can pick up your radio show in the morning now on their computers, which have a wireless connection thanks to 3G spreading throughout even the poorest regions of the world. Agriculture has some real potential with high yield seeds and with new farm techniques. But what I find in this project and in the work that we're doing with these communities, water is not only is it, as every proverb in the world says, is it life, and not only is drought the most frightening part of this whole project, but water is the one thing where there is, in everything we're doing, where there is no easy solution, right, when places don't have it. Water is expensive to move. It's expensive to pump. We're doing some of that because that's sometimes the only solution. But you realize that it's not like the wonder of the $10 anti-malaria bed net, a miracle for saving lives. When drought comes, even if you're worrying about it, preparing for it, it is so horrendous. And the options are so limited. They exist, but right now we don't have the ready-made solutions, and this is the kind of problem that in the drylands of the world, the places that on average already get little rainfall, we should expect to see really quite urgent, harrowing, and unfortunately rather frightening developments unless we're a lot more clever and a lot more consequent in addressing them.
Is there a consensus about what should be done? I mean, does technology, do governments all point to something and say this is what we need to start doing?
Well, I mean, and I have, as you know, a chapter on the Aral Sea in Central Asia in my book, and it's sort of a poster child of how not to handle water. And you have a system there where the Soviets embarked on this massive collective agricultural irrigation system in the late 1950s and early 1960s, tapping into the rivers that fed the Aral Sea at that time, the Niles of Central Asia, if you will, and then a series of
getting thirsty.
Flood irrigation projects that were very inefficient and would wash over the farm fields on the upper stretches of the watershed and then go back into the river, and then they'd wash over the farm fields in the lower stretches. And so you have the minerals and the salts from the watershed accumulating in the freshwater rivers to the point where by the time they're doing the flood irrigation on the fields towards the lower end of the watershed, when I was traveling through the fields were covered with what looked like a fine snow, but in fact it was salt. And so by using irrigation the way they were using it, they're slowly poisoning their land. So they're ruining their water and their land at the same time. So I'm glad that Professor Sachs brought up technology. I mean, there are fairly simple ways to teach them how to change their irrigation system. They have to irrigate to get the crops like cotton for Western currency. Then we could export technologies there that help them use their water and their land in a more efficient way, thereby hopefully, if not completely heading off an agricultural crisis, then hopefully forestalling it for many years to come, just as one example.
Yeah.
It is a rule of unintended consequences like the Aral Sea, but they're also so much part of the story of humanity right now and so much part of the story of water. Another technology which has been a lifesaver and a breakthrough technology was the so-called Green Revolution in India, which then spread over the world. And what that was, in essence, was improved seed varieties that have a lot more potential grain yield, mainly rice, wheat, and maize. And it comes, the green revolution technology requires high yield seed, it requires more fertilizer use, and it requires water reliably to irrigate the crops. So India, of course, was a region, a subcontinent, a civilization that had chronic crises of famine and repeated spells of famine over the last 2 centuries, and it had a major famine in the 1960s, which provoked the Rockefeller Foundation and its great scientist Norman Borlaug to team up with the Indians to introduce this marvelous breakthrough technology. And the reason I mention this in this context is that they achieved a breakthrough in grain production, and they haven't had a famine since the 1960s. But what happened? Well, what happened was that the advent of the Green Revolution, which now made the ability to grow food so much more productive and more viable, together with the development of a very inexpensive little diesel pump, led to individual farmers throughout the Ganges river plains driving bore wells down to tap the groundwater to fertilize their fields. And for a long time, that was another wonderful thing because it led to this phenomenal boost of food production. Food security came. But one of the things that happened since the 1960s was that India's population doubled. It went from around 450 million at the start of the Green Revolution to nearly 1.1 billion today. And that farm system, so productive compared to the traditional farm system, led to perhaps 30 million bore wells being drilled into the aquifers of the Indo-Gangetic plains. The water tables are now collapsing, but they're collapsing on a food system which has to feed hundreds of millions of people, as many people as there are in the United States. And it's actually hard to contemplate a problem like this, frankly. It's so big that when our lead hydrologist at the Earth Institute, a wonderful scientist who's deeply concerned about this, went to see the engineer, the water engineer in the Punjab, which is one of the center states of the Indian Green Revolution, and reported to him that after a week of surveying villages and communities that he's found water tables collapsing, the engineer basically said, yes, but what do we do about it? Because there is no obvious response right now. I have to say there are a lot of potential responses. But let me add one piece of complication on top of something already pretty complicated, and that is that the whole river system of Pakistan, not exactly the happiest place in the world right now, India, Bangladesh, and large parts of Southeast Asia and China run off of the Himalayan Tibetan plateau. That's the headwaters of all the great rivers, the Ganges and the Indus and the Brahmaputra, the Salween and the Irrawaddy and the Mekong and the Yellow and the Yangtze rivers. And the glaciers are filling those rivers now, but the glaciers are disappearing. And the estimate is that for at least the Indus, the river flow could drop as much as 30% when the glaciers disappear. There will still be river flow from the monsoons, but the glacier feed will disappear. Well, Pakistan's population has gone up 4 times from independence. It was 40 million, now it's 180 million. A lot of hungry people. It's on a demographic trajectory to reach 300 million people. Think about that, ladies and gentlemen. And they're in a climate crisis already. That's a desert country with rivers that run through it. Now the rivers are going to lose a lot of their flow.